Sprinkle sand on a metal plate, then play the right note underneath it. The sand does not scatter. It leaps into a perfect, geometric pattern. Stars, flowers, spider webs, out of nothing but a sound. So how does a noise draw a picture? Here is what almost everyone assumes. The sound is shaking the plate, so the sand must pile up where the plate shakes the hardest, where all the energy is. It feels completely obvious. And it is exactly backwards.
Backwards? How can it be backwards?
The sand runs away from the shaking. It gets bounced off every part of the plate that is moving, and it can only come to rest where the plate is not moving at all. Those still lines have a name. They are called nodes. So the picture you are looking at is not the loud part. It is a map of every place that stayed perfectly quiet. And a plate cannot ring at just any pitch. Like a bell, it has its own favorite notes. Hit one of them, and the whole surface locks into a standing wave. A fixed grid of regions heaving up and down, pinned along lines that never budge. The sand just makes those invisible still lines visible. Change the note, and the grid changes with it. A low note gives you something simple, a cross, or a single ring. A higher note shatters it into something intricate, with far more lines. But the exact shape is not really the sound's. It belongs to that plate. Its size, its metal, the spot where you hold it. A different plate, playing the very same note, draws a completely different picture.
So if I just to draw the same lines,
And now the strangest part. Swap the sand for a very fine powder, and it does the opposite. It gathers on the loud spots, the exact lines the sand refused to touch. Michael Faraday worked out why back in the 1830s. The shaking plate stirs up tiny currents of air, and those currents lift the lightest specks and carry them to the loudest points. Do the whole thing in a vacuum, with no air at all, and the fine powder snaps right back onto the still lines. So the heavy grains follow the plate. The light dust follows the air. So the sound is not really drawing anything. The plate is quietly deciding where to hold still, and the sand is only settling into the calm. More than 2 centuries ago, a man named Ernst Chladni bowed metal plates exactly like this across Europe, and helped start the whole science of sound. So look again. You were never watching the noise. You were watching the silence. Which one did you think the sand was showing? The loud parts or the quiet ones?